Today we are going to continue with the strategy that we were working on. We were trying to predict the Bitcoin price in a very short time frame. So let's review a little bit the notebooks that we were using. So the first one, we were downloading the candles. So we use 1 second candles for Bitcoin. We get the candles of the last day and we dump it. And the second thing, this feature engineer notebook, what it was doing was loading the candles from the cache, in the triple barrier method. This will, I don't know if you remember, but this method will basically add these 3 barriers, right? And we'll label the observation between 1, 0, and -1. What this gives you, the ability to understand where the next movement will go. So we are trying to predict if the price in a certain time window will go up, below, or will stay in the same value. And then we were adding a few indicators that are these TABB bands. We were adding the Bollinger Bands here. We were adding the MACD too. We were adding the RSI. We were adding a few means, the ATR, the ADX. We were normalizing all the indicators. There is an important thing here that is not trivial for AI. It's a kind of adapt of how to do it properly when doing the inference. And the thing is that when we need to do the inference, we will need to compute all these parameters, like again, and then do the normalization and the prediction. So the thing here, or what is the complex part, is that this scalar, we will need to, at some point when doing the fit transform, we will need to dump a version of the scalar, like the model in a pickle. We will need to probably pickle this. Why? Because we are fitting the standard scalar with certain variables that later on we need to use the same logic to process the new variables. This is because we assume that the distribution should be the same as before. So if not, let's say that now we have let's say that we have a new data set, right? And we only have 2 observations. If we want to do fit transform to do 2 observations, the values are going to be completely different. So the scalar that we are using to do this training has to be the same one that we use when doing inference, like the checkpoint of the scalar. So that's another thing that we will need to do it. So, well, and the last notebook, just to finish the recap, this one we didn't check it yet too much, but I think that we didn't even run it, I don't remember. But based on the file that has all the data processed, we were training a model to understand if it's working well or not, if it has good accuracy or not. So these were like the steps that we saw last week. The idea of this is just to don't rush and be a little bit progressive. So you week by week you have to work on this a little bit today to finish all the pipeline, create the controller, so we can have like a version of the controller, initial version of the controller, and then probably put it to run. We are very basic model. We don't need to have like a perfect model to run this. We just need to have something that can produce a signal, and based on that signal do the trading. I think that we can start. For now, we're going to run this notebook. The problem that we had last week was that the observations of 0 were a lot. Let's download the data again. Let's download data for 3 days. And now let's see in the feature engineering how we can reduce this. So the barriers that we are setting, the most of the observations are not 0, so they are more like other values. So I think that we discussed this last week, is like the most of the observations that we were labeling, like this one, like the most were 0. So in that case, if all the observations are labeled as 0, the model will tend to classify the observations more as 0. So we didn't have like any observation as 1 or -1 when doing the prediction. So we're going to reduce a little bit the barriers. So, well, the plot is here. This is like the 1 second candles. Okay, so this notebook is done. Save. Now feature engineering, we're going to load those candles. Let's see what's the distribution of the candles. Let me put like this. We're going to use close type, right? Close. Let's put the fees are going to be 0 because trade cost. Let's put 0 because we're going to use the FD-USD pair. Close type. Let's see if we can do like 3 and 3. And ST span, let's put like 1000, so it's like bigger. I don't know. Target. The target is the standard deviation that we are multiplying for the barriers. So it's like this barrier can be like 3 STDs, and we are using 1 second candles. So this is like, let's say that we take the median, it will be 0.04 times 3 is 0.01% is what we are predicting. It's very tough. We are predicting like 0.01%. So now this makes a little bit more sense than the other one, but it's still in balance between the long and short. So let's put like 4 and 4 as well, or 3.5, 3.5. It's strange that there are no more ones in the graph, and on this is like 5 minutes. So the barrier is something like this value. This is like what we are predicting. We probably need much more observations. Maybe we are losing observations. DF, shape. Because I was doing only for 5,000 observations, but we have a bunch of observations. We have like 260k observations. Now the dataset is much more better than before. So yeah, let's add this and let's dump the file. Okay, so now we have this features df, that is the one that we just dumped. And now let's restart this one and let's train the model now with that dataset. Now let's see how much time we take to train. It's like 260k observations. Oh, that's very fast. Precision recall. It seems like it's not that good, this model. When doing predictions, you have 4 potential stages of the value. There is like true positive, is that if you say that it was 1 and end up being 1. False negatives, so when you said that is not 1 and it is 1. Then you have false positives, when you said that is false but it wasn't false. And true negatives, when you said that is false and end up being false. Precision is for all the ones that you said that were positive, how many were positive in reality. And the recall is for all the ones that were really positive, how many did you get? All the dots that you're seeing here that are solid are really positive values. The ones that are not solid are the false, or the negatives. So what I think that we need to optimize in this type of problem is the precision, because what it means is that if we say that it's a long, we don't want to miss. It's like I prefer to take only the chances where the prediction is that it's going to be long, right? So that's like probably one of the takeaways. Is like we would like to optimize probably for precision. So the precision of short is 0.32 and the precision of long is 0.30. So this means that when we say that it's short, only the 32% of the time we make it. Now here we have a problem. This features df should not have those variables. We are putting df to parquet. This is the biggest problem. Is df processed to parquet? Okay, we changed the dataset and we have a worse result. Let me see if we can improve it. I will share this to cloud, and I will say that's the result of the algorithm. I think that we can improve the model, or at least reduce the number of class 0, since the let me go here. Since the value counts of closed type is this. Let me see what it says, but basically I think that we can reduce the number of zeros, because as you can see it's 50% almost of the samples, and that will introduce a bias. So what we would like to have is like a more balanced data set. I don't like the imbalancing thing. I don't like the using smooth. Why we don't reduce only the most similar ones? Regarding to this, that is happening now, is like it's very common in machine learning when you have the classes that are not balanced to generate a type of to use a type of algorithm to balance the classes. So there are two main ways. One is to reduce the samples. So if there are, like, for example, a sample that is very similar to the other, you usually reduce the number of samples in that way. Let's say that this observation is really similar to this observation, to this observation, to this observation. Like, let's say that all of them are really similar. What it's going to do is to reduce those type of observations. So we are like avoiding sending similar data to the model to train. So we are not like overfitting that to the model. If you don't have too much data, that's a bad thing. So that's a problem. Here we don't have that problem because we have like second candles, so we have 260k of observations. That is like undersampling. The other way is to do oversampling, that basically we create like synthetic observations of the minority classes. But I don't like that one. It's like, that one is the one that I never liked, because it's like why you're going to reinforce something that you don't know if it's that way. So it's like, I don't like. I prefer undersampling based on this. But well, let's see what it's doing here. Feature columns. Okay, this is a very good approach. What it's doing is basically using k-means. That k-means is an unsupervised learning method, a machine learning model that is unsupervised because you don't have exactly like the class that you want to predict. It's more to infer something about the data. So in this case, what it's doing the k-means is identifying what are the potential clusters. Then here we'll sample and reduce those values. So I think that is going to be interesting. Let's accept this observation. Now let's move it to the notebook, because we are doing this in a notebook. So let's copy this. Need to install XGBoost. XGBoost. So let's see what happens if we run it. Maybe we need to install it with Conda. Maybe pip is not resolving properly. Like GVM, let's go to the model part. So this is the model part. Let's replace it here. Perfect, and now let's replace this here. Okay, so we run this. Let's do the following. Light GVM. Let's see if this resolves all the dependencies that we need. There is still a dependency issue. Copy cell output. Okay, I think that we need this. Let's try this instead of what we were doing before. Okay, seems like with this installation, sometimes it's better to go to the docs rather than I didn't have the environment activated. I didn't have the environment activated, and it's required to do this stuff. Now we have a working version of what we were doing. So initial class distribution, that is what we have. I need to add to the environment.yaml the dependency of XGBoost later on. We are probably on this step. Now soon we are going to see the balanced class whatever, and then we need to the process of running training the model will happen. I think that we are not going to do too much extra. We're going to dump the model in a pickle, and then we're going to code the controller so we can predict and use the controller to predict. So that will be basically all. I want to dump the XGB model in a pickle. Yeah, joblib is another library. Yeah, I tell the AI to dump the model in XGB In the meanwhile, let's start with the creation of the controller. Now create a controller, predict with the model. Okay, this is still running. This is strange because it never reached this part. This may be the reduced majority balanced class. Okay, now the class is not sure balanced, but let me accept this, then we're going to come back here. Let me ask for a few changes here. So first change is the method, the function. So I think that we need to rename the close to map the close type to 0, 1, and 2, and then map back after the prediction. Well, we had two problems. The first one is that it takes a lot of time to do the undersampling, so probably we're going to use the mode to do it faster. And then the other problem is that we are trying to predict -1, 0, and 1, and it's expecting like 1, 2, 3, 4, 5, like different classes. I usually just add 1 to the close type and -1 once. Yeah, that's Rush Junior. That's a very, very good idea of how to do it, because if we add 1, it's like the short will be 0, do nothing is 1, and the long is 2. That's a good thing. But, well, this is also another potential option. First, add these lines to the notebook. So we need to remove this. Okay. I think that is there. Here. And we need to install imbalance learn that let me see how is the this is what Rach Junior says is that instead of doing this we can just add 1 and then subtract 1. That is going to be another option. pip install learn. Okay, it's like this. Okay, now let's see. Oh no. No, this is not good. Because we end up with much more observations. Co-produce the following output and incrementing the number of observations reduced from the random undersampling will be a better idea probably. It's going to be even simpler. I think that this is probably what we need. Yeah, perfect. I think that this should work, and we don't need this. We don't need this. We don't need this. This should work. Okay. Another option is to apply the balancing before. That's like probably the best way of doing it, because here we are separating between test, train, all that stuff. Maybe it's better to just do it beforehand, and that will be even better. Some reduce the number of samples in the majority class. No, we can do it like this. Get the size of the smaller classes. We can do this. Target size dot shape like this. So we divide it by 2 to get the target size, and then we add df neg df post like this. Perfect. So we remove this stuff from here, and then with this, okay, we can show this here, like the initial distribution, then let me see, balance df. Perfect. Now this y, this would be like x balanced, x balanced. We can actually then compare what you said, Raj. It's like, as we have the x and the y, and the x balanced and the y balanced, we can do the models with the two things and then compare. Probably if you want to collaborate with that, I will push this so you can create a PR modifying these notebooks, and we can evaluate different situations. That would be cool to work together with the community on something like this. So well, we have this y balanced e mapped, so this will be x balanced here, and then this, I don't care. We can print the balanced distribution. This should be here. Okay, I think that we are okay now. And this will be x train. That's why I had a discussion with a few friends about AI, and sometimes yeah, it gives me a lot of code, but most of the code has to be reorganized and all that stuff. Only integers. I think that this mapping thing might be a problem. So what I can do is to do what Raj, yeah, what Raj said at the beginning, that is just this balanced df. They can do like balance df close type is this +1. Then I don't need to do a mapping. I don't need to do anything like this. I just use y balanced. Actually, I don't need to do it here, I can do it here. Df with features, df with features, close type, +1. And then this part that we are doing the reverse mapping, this is just ypred and this would be like ytest and ypred, right? Correct me if I'm wrong, but I think that is this way. Cannot take a larger sample than population when replace is equal to false. The df negative is a closed type equal to 0. This would be equal to 1, and this is equal to 2. No, then these 2 and this is 1. Because we did the +1 here. Well, it's predicting everything long. I don't know why. Or maybe let's come back to the random forest model. Random forest. Let's come back to the random forest. Max depth, let's put 3. I know that their XG boost can lead to overfitting much more. Yeah, Rack says, to be honest, after the AI started producing that code, I got a bit lost. Yeah, that's what I come back to code by myself. But basically, just to recap a little bit, we do what we do always, that is getting this. I think that we don't need numpy, this is duplicated, so this is not necessary anymore. So let's review the code a little bit. We import the required libraries, right? So we get these libraries, then we read the data frame that we have with the features. This data frame with the features, if you remember, we get the candles in 1 second. Then we apply a few transformations. We added a triple barrier method with the labels. And at the end of that, we scale everything with a standard scalar, and then we dump it into a file. So that's the file that we are loading right now. Then we have this close type thing that we sum 1 because we're using the XGBoost that requires being 1, being a positive category. Now we're going to remove it because we're going to come back to the random forest that we were using. And then what we're saying is that as the class was really imbalanced because there were a lot of zeros, we are going to reduce the number of zeros in the data set. So in order to do that, we're going to get the number of observations that are between 1 that are longs and -1 that are shorts, divide that by 2, so it's the average, the half of the observations that we have for the 1 or -1, and then we're going to be sampling the observations of 0 with that value. So we're going to get the same number of zeros than ones and minus one. Then that is what we call our balanced DF. So the y balanced, the x balanced ends up being that stuff. And then we have this random forest class balanced. And then we have to train the model. So let's run it. You see that here the initial class distribution was 63k, 120 and 12 on this, and now we end up with the same 1 and minus 1, but the zeros are like the same. And okay, there is a problem here. The y train only has minus 1 and 0, and the y test only has 1 or 0. So it's really imbalanced. Okay, now we should be better. Yeah, perfect. Y train. Okay, now we have the classes wrongly distributed between the two things. So well, now we are at this point when the model is not totally perfect because we are not passing the 50% of accuracy over the estimation, but it is like the best version that we got up to this point. I think that once the next week we put this into a pipeline where we can do the training and all that stuff and test with a lot of parameters, we are going to end up improving probably or finding like a model that makes more sense. What we will need to do now is to go to the features engineering, and we also need to dump the scalar. Dump the scalar, import joblib. Okay. Let's move into models. Yes, the idea of today is that I will upload this so you can play with it, find new things to... Actually, it's pushed already into the main of Quants Lab, the thing that we did last week. So I will push this for this week. And it's ready to start playing around with. So we have the scalar in these models, and we have the model. So now let me move this and say I ended up using random forest, remove the usage of the look back window, and hard code in the update processed data the values as is done here. Adapt the XGBoost file, please. So I will give you a task, guys, if you want to collaborate with me on this, because we are on this together. You wanted the thing and I just start coding. One cool thing will be to incorporate that. Maybe is something for Rach Jr. Because he already mentioned about a few things about joblib and all that stuff. So one cool thing will be that instead of dumping just a scalar, that is this object that we are dumping here, the scalar.pickle, dump a pickle that is more like a feature pipeline, something like that. And what should that include is all the transformations to the data frame that we need to do. So in that case, it will be like everything that we are doing here. You see that we are in the RSI, all the same stuff that we are adding in the notebook to then do the scalar we are just dumping the scalar. Will be good to dump all the processes or the processing that we are doing for the dataset too. Why? Because imagine that in that case, the same controller that will be like, we can call it like machine learning controller if you want, will only require the pre-processing pipeline and the modeling pipeline. And then we can just make one thing that is just the modeling pipeline that can have everything. That will be like the next step. But if you want to play around and contribute with us, that will be really cool. So the next step here will be making the scalar pipeline transform the data frame with indicators. This will be something really cool, that the indicators, the steps to apply indicators are already like defined in that pickle with some potential way. Yeah. Then finish the controller and test it in production to see if Hummingbot is working well, if there is any issue to validate in terms of how the model is loading, if it takes a lot of time or not, what are the times that we are doing the predictions, all that stuff. Adding a notebook for backtesting so we can visualize our machine learning signal, to having a framework that will let us visualize the signal over time and see the boxes drawn, all that stuff. That will be also really cool. Then we need to do adding a task for automated training with Optuna. This will be a task that we can run in Docker that will be using Optuna to trigger trainings. Configure YAML for automated data collection in 1 second. Define if we require a dedicated server or service for signals, or we use a HBot instance for prediction, and then code the final solution. Signals ML signals plus automated training. Do it. So I think that those are the next steps. Probably it's a little bit optimistic to think that we are going to finish that in 2 more live streams. So probably we can like even increase the cadence, or you guys can start helping me to define this final solution. But what I think that should be like the best is like we should use Hummingbot for trading. Is like we probably don't want to have the bot that will be doing all the interactions with Exchange in charge of loading a machine learning model and doing the predictions. Why? Because it's like, depending on the number of bots that we would like to run, a lot of GPU resources will be required and are going to be like distributed on any machine that we would like to run. And the specs right now to run Hummingbot are very low. With 1 core of CPU and 1 GB of RAM, you can run Hummingbot. So that will increase a lot like the dependencies that Hummingbot will need. So for me, the best solution that we should go for is to have something like this, where we have the ML server. So in this ML server, we are like getting the candles, order book. Let's say that we have these 3 things, and then we have pipeline 1, pipeline 2, and then we have pipeline N. based on the data that you want, is going to be generating signal 1, signal 2, and signal n. The signal object should have like ID, market, side, and pro, because we should use the predicted proba. Right now we are assuming the majority class, but we can either avoid signals. And then we could send everything through the MQTT that we have. And then we have the bot 1, hbot 2, hbot 3, and so they are going to be like listening to these signals, updating the local state of the signals. So it's like this machine learning server can be in charge of just producing a bunch of signals, and then the hbot, based on the ID or whatever, can start streaming those signals and taking decisions based on that. So that would be a very cool example, because we're going to show like how to use the MQTT broker to send messages through different services and all that stuff. So well, that's basically all for today. I hope that you like it, and well, I hope that at some point in the near future we can get this up and running. I think that this would be really cool, because if we set up a cool framework, it's like, first of all, it's all documented like online, and once we put this in production, we can invite a lot of people that loves doing machine learning models to contribute their own models. So yeah, that will be, I think, that's really cool. Well guys, thank you very much for this live stream. See you next week. It will be really cool for us if you want to just start contributing, helping us in the chat. Okay, well, have a great weekend. See you next week. Bye bye.